walk through a little bit more complicated example. And in this, so we have y prime is equal to e to the x over, and we'll have 1 plus a y down here on the bottom. So in this example, we're going to run into a couple of things that we haven't seen before. So in this one, we're going to see a case where after we integrate and everything, it's not so easy just to get our y by itself, okay? So we'll run into that problem, which we'll deal with. And then also, what we're going to have given is also an initial condition, okay? So right off the bat, when we see this initial condition, we know that our answer has to be a particular solution. Okay, because now we can pin down whatever constant we get and then to formulate that particular or unique solution, okay? So let's start off just by making this y prime into dy and not dt here. And do you see why it's not a dt? That wouldn't be dt because we actually see on the right side we have an x instead, okay? So now we're assuming that our y is a function of x. So we'll have dy dx, okay? And then is equal to e to the x over 1 plus y. And now we're just going to separate. So we'll bring all the y stuff to the left side and all the x stuff to the right side. So we get 1 plus y times dy is equal to e to the x times dx. Okay, so we've separated our variables. That was pretty easy. Now we're going to integrate on both sides. All right, so we're going to get y plus 1/2 y squared is equal to e to the x. And don't forget our plus c, of course. Alrighty, so at this point, technically, we can accept this as a general solution, but we see two things are a problem right now. So first of all, we don't have our y by itself. It's kind of, there are y's on the left side, but we don't have a single like y where we can write y of x is equal to blah, blah, blah on the right side, right? So we don't see that, and we have this general constant c here, which we can't have because we are given an initial condition, so we have to use that in some way. So let's deal with the initial condition first. So what is this telling us? This means when x is equal to 0, then our y is equal to 1. Okay, so let's just plug those in and solve for c. So our y is equal to 1, so we're going to plug in a 1 here, and then we have 1/2 times 1 squared is equal to e to the 0. Okay, and then we have our plus c, so e to the 0 is just equal to 1. Alrighty, so if we subtract 1 from both sides, subtract 1, then those ones go away, the ones just go away, and we're left with c is equal to 1/2, okay? Okay, so on the next slide, I'm just going to plug in that exact c that we just found. So now our solution reads y plus 1/2 y squared is equal to e to the x, and instead of plus c, we're just going to plug in that positive 1/2 for c, so we have plus 1/2. And now what our job is, so we dealt with the initial condition, we pinned down a specific c, a specific constant, and now what we're going to do is just try to get y by itself. So that's what we're trying to do, is just isolate a single y on the left side. All right. So in doing so, we can, well, let's see. We can just multiply by 2 all around because these 1/2s are bugging me. So if we do that, we just get 2y plus y squared is equal to 2 e to the x plus a 1. Okay, so not bad. And then let's rearrange some things. Let's bring everything to the left side, okay? And I'm just going to flip these guys. They're just the order. So we'll put the y squared first plus 2y. And then we're just going to subtract everything that we see on the right side. So we're just going to plug in this minus 2e to the x plus a 1, okay? So on the right side, we're left with a 0. Okay, so I don't know if you can see where this is going, but now let's see, we have something on the left side that resembles a quadratic form, right? So what that means is we can use the quadratic formula. So in order to get y by itself, this is going to be equal to negative b, so in this case it's a 2, so negative 2 plus or minus the square root of b squared, so that'd be 2 squared, which is 4, and then minus b squared minus 4ac, so a is just a 1, and then c is actually a negative 2e to the x plus 1. Okay, so extend the square root sign there. And then beneath we have 2a, which is 2 times 1. All right, so let's just simplify. That's all we have to do now. So now we have y is equal to a negative 2 plus or minus the square root of 4, and then instead of minus, because now we have two negative signs, so those become positive, so plus, and then when we distribute the 4 in, we just get 8e to the x, and then plus a 4 here, okay? And then so this is all over a 2, okay? And we'll continue this on the next slide. So then we have y is equal to a negative 2 plus or minus, and then I'll just write exactly what we had before. So 4 plus 8e to the x plus a 4, and then all over a 2, okay? And then we can combine those 4's inside the square root. Let's do that really quickly. So negative 2 plus or minus 8e to the x plus an 8. We can factor out an 8 in there. So when we pull out an 8, we just get negative 2 plus minus. And then actually, let's just pull out a 4 for this case. Okay, because that's all that's going to come out anyway. So then we're left behind with a 2e to the x plus 2. And this is over 2. And the square root of 4, this 4 can come out as a 2. Okay, and then we can cancel those out with the denominator there. So we ultimately get that y of x is equal to negative 1 plus or minus the square root of 2e to the x plus 2, and then over 1, which we don't even have to write that anymore. But we see here, so this is equal to negative 1 plus or minus the square root of 2e to the x plus 2. So now you might be thinking, okay, we're done, right? Because now we have our, sorry, I just destroyed that negative sign there. Anyways, you might be thinking, okay, we got y by itself, our single variable function, right? And we got some expression for it on the right side in terms of x. But the thing is, we can't have this plus or minus sign still sitting there, because that means right now what we have going on the right side is two different functions, two completely different functions. So let's turn back to our initial condition, which was y of 0 is equal to positive 1, okay? And this will guide us into deciding or choosing one of these signs, the positive or the negative, okay? So let's try plugging it in. So we have y of 0, and this should be equal to a positive 1. And when we plug in 0 for x, we get negative 1 plus or minus. Right now we're still indecisive, right? So 2e to the 0 power plus 2. So this is a 1, so we have square root of 4 in here. So which one do we need in order for this whole thing to be a positive one? And the answer would be we need the positive value there, the positive sign. Okay, so we get rid of the negative sign and we just we drop the negative sign basically, and we just take the positive out. So that means that our solution is going to be, our particular solution in this case is going to be y of x is equal to negative 1 and then plus, only the plus 1, the square root of 2e to the x and plus 2. Okay, and that concludes the concepts video for section 2.2, solutions to separable equations. I hope that helped, and I'll be talking to you in the practice problems video for this section if you watch.